All right, we're about to tackle a question in physics that is so mind-bending, it might just challenge your entire understanding of reality itself.
I mean, really think about it. You and I, we live by this one simple rule, right? What's done is done. The past is set in stone. But what if it's not? What if, at the deepest, most fundamental level of reality, that's just not true?
Yeah, you heard that right. For decades now, some really bizarre results from quantum mechanics have been hinting that the choices we make right now in the present can somehow reach back in time and influence things that have already happened. I know, it sounds like something straight out of science fiction, but this isn't just theory. It's based on real, repeatable experiments. And we're not talking about just thought experiments here. Look at the delayed choice experiment. How you choose to observe a particle now seems to decide which path it took in the past. Or check out the quantum eraser experiment, where erasing information in the present can literally bring back a quantum pattern from the past that was already gone. In both of these, it really looks like the future is changing the past. So what on earth is going on here?
So this isn't just weird or hard to wrap your head around. It's a full-blown scientific paradox. It's like finding a crack in our most fundamental understanding of time itself.
Okay, so the heart of the problem is this. Everything we see, everything in our universe, moves in one direction. You know, a glass shatters, it doesn't just unshatter. That's the second law of thermodynamics in action, the unbreakable arrow of time. But these quantum experiments, they seem to show that arrow bending, maybe even pointing backward.
So how do we possibly solve this puzzle? Well, there's a new theory on the block called the Theory of Entropicity, or ToE for short. And what's cool about it is that it doesn't try to sweep the weirdness under the rug. Nope, it leans right into it and proposes a completely new way of thinking about time itself.
Okay, so at its heart, ToE rethinks what entropy even is. We usually think of it as just disorder, right? But this theory says no, it's a fundamental field, kind of like gravity. And this field is what actually generates the forward flow of time, but it also does something else, something absolutely critical. It's what makes it possible to tell one event apart from another. And this is where we get to the really big idea. The theory basically splits the past into two different kinds. First, you've got the ontic past. Think of this as what actually happened, the hard physical reality. It's fixed, you can't change it, ever. But then there's the epistemic past. This is what we can know about what happened. And according to the theory, this past can stay kind of fuzzy, blurry, and undecided, right up until something in the present snaps it into focus.
So what's the thing that makes it snap into focus? The theory calls this entropic closure. It's that exact moment when a measurement or some interaction generates an irreversible burst of entropy. This creates just enough information to make one specific history stand out from all the other maybes. And bam, in that instant, our knowledge of the past, the epistemic past, locks into place with what really happened, the ontic past. The blurry photo suddenly becomes perfectly clear.
All right, so now that we've got these new tools in our belt, the two pasts and entropic closure, let's go back and see if we can finally crack this quantum mystery. So the big question is, how does all of this actually solve the problem? How does this idea of two pasts explain how a photon's history seems to change based on what we do now? Well, here's how it works. According to this theory, while that photon is traveling through the experiment, it doesn't have a fixed past yet. It's not a particle, it's not a wave. Its past is still blurry, still indistinguishable. The measurement we make in the present, that's the moment of entropic closure. It's an irreversible event that creates a flood of new information. And it's that information that finally locks in the story, making one history, the wave history or the particle history, the one that becomes real.
And there it is. That's the solution. The present isn't acting like a time machine, going back and rewriting history. It's acting more like an editor who finally decides which version of a story becomes the official one. The actual ontic past was never touched. It was our knowledge of it, the epistemic past, that just got finalized.
But the theory doesn't stop there. It goes even deeper. It doesn't just explain how this quantum weirdness works, it proposes a fundamental reason why time has to move forward at all. A reason that's literally woven into the fabric of reality.
And believe it or not, it all comes down to this one number, the natural log of 2. Now, I know, that might just look like some random number, but according to this theory, this value is a fundamental constant of our universe. It's as important as the speed of light.
This number has a name, the Obidi Curvature Invariant, or OCI. And what it represents is basically the absolute minimum price of reality. It's the tiny, non-zero cost of entropy you have to pay to make any two things in the universe distinct from each other. It's like the universe's cover charge. If you don't pay this tiny price, you can't have separation. You can't tell this from that.
So this OCI, this number, it acts like a cosmic gatekeeper, a firewall that separates past, present, and future. Because every single event that you can tell apart from another one has to pay this irreversible entropic cost. The arrow of time isn't just a suggestion anymore. It becomes a non-negotiable, structural feature of the universe.
Let me put it as simply as I can. The very act of being able to tell things apart, the fact that we could even have a sequence of events we call history, is what forces time to have a direction. You just can't have one without the other. The arrow of time exists for one simple reason, because we can tell things apart.
And that leaves us with one last, really fascinating thought. This theory suggests that the forward march of time, something that feels so absolute and fundamental to us, is really just a side effect of something even deeper, the universe's basic need to make things distinct. And it really makes you wonder, if our ability to tell one moment from the next is what literally builds time, what else in our reality is built on that same simple, profound foundation?